Alright, so I want to explain how to graph cosecant and what the period, where the vertical asymptotes are, what the domain is, what the range is, if there's any zeros, over what range is it increasing and decreasing, and also I want to introduce the idea of as a value is approaching from the left to the right, what is the actual end behavior of the function doing? Alright, so the first thing you want to do, cosecant is really the reciprocal of sine. So cosecant theta is really the same thing as 1 over sine theta. So the way that I graph these is I start by graphing sine. Once I graph sine, then from there I'm actually able to graph my cosecant. So let's see how well I can do this freehand here. Sine starts at 0. I'm going to have a maximum at pi over 2, back through at pi, minimum at 3 pi over 2, and back up at 2 pi. Now that's the sine wave, but we are still trying to graph the cosecant wave, not the sine wave. Well, what's nice about the sine wave is because cosecant is indeed 1 over sine, everywhere sine touches the x-axis, you're going to have 1 over 0. Well, if you have 1 over 0, that actually is a vertical asymptote, which you have one right here at 0. You have one right here at pi. And you have another one at 2 pi. Now, what's nice about the cosecant is essentially the maximum and minimum points right here and right here are still going to be, they're going to be the boundaries in which you start. So really from the maximum, you just draw from the maximum up to your vertical asymptote, go in both directions. Down here, you go from down. That is essentially the cosecant graph, the green graph here. This part and this part is the cosecant graph. Alright, so now let's answer these questions here. What is the period? What is the vertical asymptote? What's the domain, range, zeros? Where is it increasing and decreasing? Well, the period is going to be the same as sine. It is 2 pi, because after a little while, after 2 pi, it starts to repeat itself. So our period is still 2 pi. My vertical asymptotes is everywhere. You're going to have x equals k pi, because the asymptotes are on multiples of pi, such that k is an element of the integers. Now I gave you guys a list of all these different symbols. You're going to have to be able to start understanding and reading them. If not, it's going to be a tough year. Okay, domain. My domain is basically every real number except for the vertical asymptotes. So really, my x just cannot equal k pi such that k is an element of the integers. It's every real number except for where the vertical asymptotes are. My range. Well, my range is essentially any number. It's going to be all my y values, but if I take the absolute value of all my y numbers, it has to be greater than or equal to 1. Now that includes the positive and the negatives because of the absolute values. My zeros, well, if you just look at the graph, it doesn't touch anywhere. So the basic graph, there are no zeros. It's not applicable. Now, once you start moving up and down with transformations, you can still get zeros, but for the basic parent function, there are no zeros. Now the tough part. Where is it increasing and decreasing? What does it mean for increasing and decreasing? Well, what it means for increasing and decreasing is essentially you're going to go from left to right. So we're going to start right here. Well, from here, from 0 all the way up to pi over 2, you're decreasing. And from pi over 2 to pi, the graph is actually going up, so you're increasing. And then you jump back over here on the other side of the vertical asymptote at pi. As you keep going, it's still increasing to 3 pi over 2, and it's going to decrease from 3 pi over 2. Now, because this is a product of the sine wave, it goes out for infinity in both directions. So it's going to increase and decrease over an infinite amount of intervals. So we just have to use a tricky little way of writing the notation. So here we go. It's going to be increasing from dot, 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 union. Now, at the points in which it changes from increasing to decreasing, there is no slope. Therefore, it's not increasing or decreasing. So for our interval notation, we use a soft parenthesis. We don't use a square one because it's not going to actually be increasing or decreasing at that point. It's increasing from pi over 2 to pi union. It is also increasing from pi to 3 pi over 2. Let me clean this up, write it a little better. It's from pi to 3 pi over 2 union dot, dot, dot. Well, the 3 dots here means it's going in the same direction from negative infinity all the way up to infinity. All right, let's talk about where it's decreasing. We have to do the same method. We're going to go from dot, 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 union. In this case, it's decreasing from 0 to pi over 2 union. And then it's also decreasing from 3 pi over 2 to 2 pi union dot, dot, dot. Well, that's basically how you're going to have to write the increasing and decreasing, because it's increasing and decreasing on basically the set of all real numbers. It's going out from negative infinity to infinity, so you just can't list one or two things unless you just do what we call cutting a function, and you're only looking at a specific range of numbers. In this case, we're not looking at a specific range of numbers, so you have to include everything. All right, the last thing I want to talk about is the idea of if I give you a number, and basically you want to approach that number from the left or to the right. Here's how we're going to write it. We're going to say, well, I want to give you x. It's going to approach, let's just pick pi from the left. The little minus up top means from the left. My end behavior, what is it going to equal? And we're going to do the same thing, x, as it approaches pi from the right. The plus means right. What is essentially the end behavior of this graph? Alright, so this is how you really just kind of look at it. So we're going to take pi, we're going to find pi right here. It's this asymptote right here. And the reason why I say end behavior is because I picked an asymptote, so you're looking at the end behavior. But you could do this with any number as well. We could say pi over 2, and as what is x at, what is your y value as x is approaching y over 2? Pi over 2, sorry. But let's just look at pi. So this reads x approaches y from the left. So let's do that. We're going to go towards pi from the left on the graphs. Well, we're going to start here, and we're going to approach pi from the left. We're actually going all the way down to negative infinity, because we're looking at the y value. F of x is a fancy way of writing y. So we're going to say my y value is going to be negative infinity here. So when my f of x is actually approaching pi from the left, it's actually going to be negative infinity. Negative infinity. Now, when we go back and we look as x approaches pi from the right, the plus means from the right, well, we're going to go here. We're going to do exactly that. We're going to move, basically go right towards pi, and what is the graph doing? What's my y value? Well, in this case, it keeps going up. It keeps going up to positive infinity. So, x, as it approaches pi from the right, my f of x is actually going to be infinity. you're going to use this notion here. You're going to need to know this for when we're taking tests, and you're going to need to know this when you go to calculus. By knowing this notation is going to help you when you get to calculus. Alright, so that's it for graphing the cosecant equation, cosecant function. Secant's the same way, but instead of it being 1 over sine, it would actually be your secant. Secant of some angle is really 1 over cosine. So you would actually just simply graph the cosine wave and follow the same procedure. Just like we can turn a sine wave into a cosine wave, we can turn a secant wave into a cosecant wave. The period's going to remain the same. Your vertical asymptotes are going to change a little bit. The domain's going to change a little bit. The range is going to be the same. The zeros are going to be the same. Increase and decrease are going to change. And as x approaches pi from the left or right, if you pick vertical asymptotes, just simply the angle is going to change. Because the question we're going to ask you is towards the asymptote. With that, we'll go over this in class. We'll go over this one as well in class. I'm not going to make a video on it. It's essentially the same. You'll be able to look at your notes to be able to get the rest of these answers right here. And we'll talk about tangent and cotangent as well.